Assalamualaikum warahmatullahi wabarakatuh and a very good evening to everyone. My name is Azhana Al-Humaira binti Azhan. My metric number is 200672.
My name is Muhammad Irfan Shakir bin Nur Hadi and my matrix number is 200322.
Okay, so for today's experiment, we will be presenting to you experiment 2 with the topic synthesis of potassium trioxalatoferrate 3 trihydrate. Okay, so the learning objective for this experiment is to describe how to synthesize potassium trioxalatoferrate 3 trihydrate complex, to study the use of titration technique and UV spectroscopy in determining the content of iron and oxalate ions, and lastly, to derive the experimental formula of the complex. Okay, for the first part of the experiment, we will be preparing pure sample of potassium trioxalatoferrate 3. Okay, so this is the picture of the molecule. The central atom is the iron with +3 oxidation state, and it has 3 bidentate oxalate ions, which is bound to the iron center. It is an octahedral shaped geometry, and the color of this compound is emerald green. The materials needed for this experiment is ferric chloride anhydrous, potassium hydroxide, hydrated oxalic acid, hydrated potassium oxalate, ethyl acetate, cold water, and distilled water. For the apparatus, we need wash glass, measuring jars, china dish, black pepper, Bachner funnel, trough, spatula, filter paper, sandbath, glass rod, and beakers. Okay, so for the procedure, this is the first part of the procedure. 3.5 gram of anhydrous ferric chloride will be added in a 50 milliliter beaker, and this 50 milliliter distilled water will also be added to the beaker. The solution will next stirred to dissolve the ferric chloride, and then in another 250 ml beaker, 4 gram of potassium hydroxide and 50 ml distilled water are added and stirred in order to dissolve the potassium hydroxide. Next, the potassium hydroxide solution are added to the ferric chloride solution and in small proportion with constant stirring. So as you can see in the picture, the color of the solution will be brown color. Okay, next, it will the precipitate of ferric hydroxide are filtered through a Bachner funnel, and the precipitate are then washed and transferred to a wash glass. For the second part of the experiment, 4 gram of hydrated oxalic acid and 5.5 gram hydrated potassium oxalate are added in a 250 milliliter beaker. And then 100 ml distilled water are added and stirred with the solution. The ferric hydroxide precipitate are added in small proportions into this solution. Then this solution is constantly stirred until all the precipitate are dissolved. If the precipitate is not dissolved, we need to heat the solution and continue stirring until all the precipitate are dissolved. Next, the solution is then filtered into a china dish using a funnel and filter paper. The mouth of the funnel need to be at the side of the china dish so that the solution wouldn't splash outside the china dish. Then the solution in the china dish were heated on a sand bath and stirred continuously to prevent crude from forming. Next, a drop of solution are took out after the volume of the solution were half of its initial volume and cool. The drop of the solution is took out using a glass rod, and we will cool it by blowing on the glass rod. Okay, we will continue. As you can see, in the picture, there is crystal forming at the glass rod. So it means that crystallization has occurred. So the china dish is placed, the solution inside the china dish is placed in trough containing cold water and covered with black paper and let it cool for some time. And then we can observe that emerald green crystal of potassium trioxalatoferrate 3 are separated out from the solution. So next, the liquid are decant carefully into a beaker for us to separate the solid and the liquid of the solution. And then the crystal are washed with ethyl alcohol for 2 or 3 times in order to purify the product. The crystal are then removed from the china dish to a filter paper and pressed with another filter paper gently to remove any liquid that is still there. And then the crystal are transferred to a watch glass. The final product you can see in the picture, potassium trioxalatoferrate 3 are in emerald green color. For the precaution steps, here I listed 4, which is not in the video. So the first precaution step is that the solution need to be transferred by pouring down a glass rod, poking into the beaker or funnel to avoid spills, just like I told you guys before. And then the second one, the solution need to be stirred continuously while adding the ferric hydroxide precipitate. The third precaution step is the stem of the funnel should touch the wall of the china dish to avoid solution from splashing up. And lastly, crystals formed should be washed with ethyl alcohol and not distilled water. Okay, we will continue to the next part of this experiment, which is determination of oxalate contained in an unknown complex. Okay, so basically, this experiment is about redox titration. So the indicator that we use is the excess permanganate ion, which is purple in color. And then the unknown is the solid sample containing some of the percentage of oxalate ion. So the materials needed for this experiment is sodium oxalate, potassium permanganate, sulfuric acid, and water, and also other basic apparatus. For the procedure, sodium oxalate is weighed and added into a 500 ml Erlenmeyer flask. This is because the solution will have a large amount, so so we need to use a 500 ml Erlenmeyer flask to prevent the solution from overloading the flask. Next, the sodium oxalate are dissolved in 200 ml water and 1:1 of sulfuric acid water. The next step is solution is heated for 7 to 10 minutes on a hot plate, and then the solution is titrated with potassium permanganate until it appears as purple in color, just like the picture shown at the right side. That is not the end point of the titration yet. It is just the beginning of the titration. So then the titration is proceed into the solution and swirl until it become colorless. Once the solution become colorless, we will continue titration as always until a faint pink color is observed when we titrate with the potassium permanganate. Once you can see the faint pink color, so it indicates that end point of our titration.
Okay, for the next part, UV vis spectroscopy. What is UV vis spectroscopy? The UV vis spectroscopy is the measurement of attenuation of a beam of light that passing through a sample or after reflection from sample surface. This is a schematic diagram for spectrometry. First, we need light source, monochromator, sample holder, detector, and recorder. And this is the instrumentation. First, light source emits polychromatic radiation to monochromator. Monochromator converts the polychromatic radiation into monochromatic radiation. This monochromatic radiation contain light that have only one specific wavelength. Then The light will pass through sample holder containing sample solution, then to the detector. After that, the recorder will receive the electric signal from detector and displays it in form of graph. This is spectrophotometer. The control panel is the button. The chamber is the place to put the cuvette and the lid. Step to use UV vis spectrophotometer. First, we need to do a blind solution scan for both reference and sample. Then, rinse the cuvette with solvent being used. Shake and dispose it to the waste beaker. We need to repeat this 2 times. Next, clean the transparent sides. This is to remove the fingerprints, grease, paper links, droplets. This to avoid light rays being refracted. Insert the cuvette in which the transparent side in east-west direction where the light comes from. Then place 2 cuvettes into the blank and sample holders accordingly. Close the lid and do auto zeroing. After that, press button 2 on the control panel to access spectrum. Press auto zero. Then take out the sample cuvette, rinse with sample solution multiple times. Pour the samples into the cuvette. Rinse with the sample used and dispose it. We need to repeat this 2 times. After that, fill the cuvette to 4/5 of head with the solution. Clean the transparent sides. Place the cuvette into the sample holder and close the lid. Last but not least, press start. Press F1 to zoom, press F3 to scale, press F2 for data processing, then press 3 to see the maximum absorption wavelength and absorbance value. Press F2 to print the spectrum result. Okay, next, the use of Beer-Lambert law to determine iron 3 content in the complex. This is the equation of Beer-Lambert law. A equal to epsilon times L times C, where A is the absorbance, epsilon is the molar extinction coefficient that depends on the nature of the chemical and the wavelength of the light used. L is the length of the path light that must travel in the solution. The size of cuvette usually 1 cm. And C is the concentration of a given solution. The Beer-Lambert law states that there is a linear relationship between the concentration and the absorbance of the solution, which enables the concentration of a solution to be calculated by measuring its absorbance. So the sample concentration can be calculated by converting the Beer-Lambert law formula, where the concentration of iron 3 ion is equal to absorbance divided by length times epsilon. Therefore, the concentration of ion 3 that content in the complex can be determined. Okay, that's all from our presentation. So let's move to the Kahoot quiz.
Thank you.